Hello and welcome to the Did You Get It for Lesson 4.1. This lesson is starting our unit on statistics. And this lesson in particular is about, so you're saying there's a chance. So we're really just working on some good understanding of some of our definitions. The first Did You Get It that we're going to look at is on page 367 at the bottom. It is going over and using our understanding of outcomes and events. So reminding you that an outcome is the result of a single trial of a probability experiment on page 366. And then an event is a collection of one or more outcomes in a sample space. Some events, like rolling a 3 with one die, have only one outcome. Others, like rolling an odd number, have more than one outcome. So, did you get it? Number 1 says, a baseball team has 12 pitchers on the roster, and the manager, who evidently is intent on losing his job, decides to pick the starting pitcher for tonight's game randomly. What is the sample space? Write an example of an outcome and an event. So, the sample space usually we would list them in brackets. Well, it would be all 12 pitchers. Now, if we had their names, we would list them here. And then an example of an outcome would be if you choose one specific pitcher. Because that's just an outcome is the result of one trial. An example of an event could be choosing a right-handed pitcher, because more than one of the pitchers would qualify for this. That's why it's an event. So next, did you get it? If you turn to page 370, it says there are 75 balls in a bingo hopper. The ones numbered 1 through 15 are labeled with a B. The ones from 16 to 30 labeled with an I. From 31 to 45, they're labeled with an N. 46 to 60, they're labeled with a G. And from 61 to 75, they're labeled with an O. Find the probability of these events. What is the probability of drawing N42? Well, N42 is a specific ball, and it's an N because it's in the ranges of 31 to 42. So it's N42. So there's only one of those. So let's rewrite this. We're going to write this as the probability of N42. That's how we write that. The probability, P for probability, and then what you're finding the probability of in the parenthesis. And because there's only one out of the 75 outcomes, that's how we would write that. Then B says, what is the probability of drawing an N11? Well, I'm going to go back to my description here. To B and N, they have to be numbers 31 to 45. So there is not a ball that has an N and an 11. So this would just be 0 out of 75 or 0. Because none of the balls satisfy that. C says drawing a number less than 50. So again, we're going back. So all the numbers less than 50, there's 75 balls, and number less than 50 means that 49 of the balls are less than 50. So C would be 49 out of 75. And then D says, what is the probability of drawing an odd number? Well, we have 75 balls, so you've got 1 through 75. And so that means that there would be 38 of them, because if you had 74 balls, it would be 37 of them would be odd and 37 would be even. But because we have a 75th ball and you start with 1, which is an odd number, that means you have 38 of them that are odd. So that would be 38 out of 75. Then did you get it? Number 3 says, in the game of rock, paper, scissors, 2 people play, and it's equally likely that you will win, lose, or tie. Find the probability of losing twice in a row. Okay, so twice in a row would be, you can either win, lose, or tie. So that means that I've got 1/3 of a chance of winning. I've got 1/3 of a chance of losing. I've got 1/3 of a chance of a tie. So losing twice in a row would be the probability of lose and lose. Now they should be independent of one another. So that means I can multiply their probabilities together. So that would be 1/3 times 1/3. And that multiplies to be 1/9. Then B says, what is the probability of winning at least once in 2 tries? So at least once in 2 tries. So 2 tries, I've got, I could make a little tree here. So try number 1, I could win, lose, or tie. And they're each 1/3. And then on try number 2, I could win, lose, or tie. And I could also, if I lost on the first one, I could still win, lose, or tie on the second try. And the same with if I tied on the first one, I could still win, lose, or tie on the second one. And each of these are again 1/3 if we fill this out. So losing and losing, if we go back to A, we could see this in the tree here, that losing and losing would be losing and losing. This right here would be a lose, lose. But B says winning at least once in 2 tries. So winning at least once means I won on both. And then here I won on the first one and lost on the second. And then here I won on the first one, but tied on the second. But those all count because I won at least once. And then if I lost on the first one, I could win on the second. So that would be a loss and a win. And this no longer counts for part B. And here was a loss and a tie, and that doesn't count. Because B is at least a win, at least one win in 2 tries. Now, if I tied on the first one, I could win on the second. So that would also count. So 1, 2, 3, 4, 5 of the outcomes out of the 9 outcomes is where I win at least once. So 5 out of 9. And then C says, what is the probability of having the same outcome twice in a row? So that means that would be the win-win, or here would be lose-lose, or tie-tie. So there's 3 outcomes where you have the same outcome twice. So that would be 3 out of the 9, or that could be reduced to 1/3. Then we have did you get it number 4? So let's go ahead and move forward. Did you get number 4? Says, for the docket problem in question 10, what's the problem that a juror gets assigned to a case that isn't a drug offense? So we have to go back to number 10. Number 10 said of the next 32 trials on the docket in a court, 5 are homicides, 12 are drug offenses, 6 are assaults, and 9 are property crimes. So it says, what's the probability that a juror gets assigned to a case that is not a drug offense? So that means number 4, the probability of not a drug offense. This is where we're talking about complements. So we could also say that's equal to the probability of drug offense. And we could put a C here for complement, or you could put a prime. They put the little prime symbol. So that means not a drug offense means we could count all the ones that are drug offenses and subtract them. Or we could just count up all the ones that are not a drug offense. So all the ones that are not a drug offense would be homicides are not a drug offense. So that would be 5 out of the 32 there. Plus 6 assaults are not drug offenses. 9 are property crimes. Those are not drug offenses either. So that would be 5 and 6 is 11 plus 9 is 20 out of 32. And we can divide 20 and 32 by 4 each. So that leaves us with 5/8. We look at, did you get it number 5 on page 377 here? The bottom of page 377. Let's look at that one next. It says a 2-pound bag of Hershey's miniature contains 33 milk chocolate bars, 27 crackle bars, 26 Mr. Good bars, and 19 special dark bars. Set up a frequency distribution and find the probability that a bar chosen from a randomly selected bag is of Mr. Good bar. So a Mr. Good bar is 26 of the total. So if we first we have to find out how many are in there altogether. So that would be 33 plus 27 plus 26 plus 19. Looks like it's oh, so that would be 60 and 45 is 105 total. So A for the Mr. Good bar would be the 26 out of the 105. And if we looked at that on Desmos, that comes out to be rounding to 3 decimals, 0.248. Part B says, what about a crackle or special dark? And so because we consider these mutually exclusive, they cannot happen at the same time. We are able just to add their probabilities together. So the probability of a crackle is, oh, yeah, crackle is 27 plus the special dark, which is 19 out of the 105 is going to be 46 out of the 105. And that comes out to be 0.438 when rounded to 3 decimals. And then letter C says, not a milk chocolate bar. So this means we're saying the probability of a chocolate complement because we don't want the chocolate bar. It's not a milk chocolate bar. So that means we can use our complement rule as another way to practice. So we could say 1 minus the probability of chocolate. That's one way to do that. So 1 minus the probability of chocolate, the milk chocolate, is 1 minus the 33 out of 105, which would be 1 minus 0.314, which would be 0.686. Or you could just add up all the ones that are not milk chocolate. This is the milk chocolate. So the ones that are not milk chocolate would be the 27 crackle bars, the 26 Mr. Good bars, and the 19 special dark bars. So 27 plus 26 plus 19 over the 105 is 72 over 105. And so that indeed equals 0.686. So great introduction to statistics here and some probability in lesson 4.1. Catch me back for another Did You Get It?